Today's date is 11/13, and the title is called Presenting Data. Alright, so that's the title of the section. This is the last section of our unit before we take a big chapter test. And so this is day 2 of the 4 that we spend in each of our levels or cycles. And so to start with, we need to think about scientists and how they go about tracking and collecting data. All right, they get lots and lots of data all the time. And one of the things that they have to do is they have to be able to organize, bless you, organize data. Okay, that's one of the most important things that scientists can do, is they have to be able to take large amounts of numbers and words and information, and they have to be able to organize it in some fashion. And they do that by putting things onto tables and graphs. So scientists put data onto tables and graphs. Because it's a way of organizing things. Bless you.
Thank you.
So we make sure that we put them onto those tables and graphs. Now, another reason why we do that is because of the fact that it allows scientists to spot patterns or trends. Okay, so one of the things and reasons why we graph things is because it allows us to be able to see any type of pattern or trend. And you saw some of that when you were doing your graphing of the M&Ms. Okay? Jamie, when you guys started out with your bar graph, all right, you had one of the bars that was taller than the other ones. Okay, which one was taller on your graph? Do you remember what color it was? Okay, orange. So when you were looking at your bar graph, you had one that was taller than all the rest. And so yours, in your case, was orange. So Jamie, what kind of statement can you make based on your bar graph about your orange M&M? What can you say about that?
It was more. The orange is more green than all the other colors.
Okay, you had the most amount of orange in your bag. Very good. Okay. And JC, when you guys looked at your circle graph, was there one slice of the circle graph that was bigger than all the other ones? What color was it? Okay, so you had orange too as being your bigger slice? Okay. Is that what color it was? Oh, okay. So let's say it was. And so if I asked you to make a statement about your orange, what could you say? Yeah, you had the most, in your bag of M&Ms, you had orange being the most, all right? Very good. And let's see, Ashton, with your line graph, did you have one dot that was higher than all the other ones?
Yes.
Okay, what color was it?
I think it was red.
Okay, your red. So what's a statement that you can make based on your red M&Ms? What can you say about that?
That red M&Ms were more red M&Ms than the color.
Very good. So what we did here is we just quickly went through and you guys were able to give me your patterns, or you saw that there was some type of trend. This one had the largest amount of M&Ms. This one had the least amount of M&Ms you could identify as well. So scientists organize data, they make sure that they put it onto a table or a graph, and this allows us to be able to spot a pattern or a trend. Okay, any questions on that so far? All right. Moving on, all right? Now that we know that we have this information that we have to be able to plot, one of the most easy type of graphs to work with is a table graph. Actually, I'm just gonna call it a table. We're just gonna refer to it as a table. Okay, bless you. A table is going to be made up out of two variables. And you are familiar with this one because of the fact that it has a t-chart. Okay, usually it's made up out of a t-chart. And one of the variables is going to go on the left side, so one variable on the left, and the second variable is going to go on the right. Alright, so if I was to give you an example, so let's take an example of, let's turn this into cities, and let's turn this one into amount of rainfall per year. Okay? And I'm going to close off this. And I'm going to draw some lines going straight across. Let's bring this down just a hair. And we could continue going down further if we needed more room to be able to make this. And let's take Kewaskum. And let's take West Bend. And let's take Slinger. And I'm just going to make up some numbers for the amount of rainfall per year for Kewaskum. Let's just say that we get 96 centimeters. We'll say that West Bend gets 94 centimeters. And we'll say that Slinger gets 86 centimeters of rain per year. Okay, so what I've done is I've taken two variables, one of the variables being location, or cities. The second one is going to be the amount of rainfall, which is going to be your variable, which is changing. And so, what's a statement that we can make based on this table that's up there? Addie, what is something that we could say based on our data up there? Okay. Yeah, we could say that Kewaskum gets more rainfall than West Bend and Slinger. Very good. Ashton, you have another one?
Yeah, Slinger gets less rainfall than West Bend and Kewaskum.
Okay. Slinger gets the least amount of rain out of the three cities, and which is less than West Bend and Kewaskum. Good. Avery?
Well, West Bend gets more rain than Slinger, but less rain than Kewaskum.
Awesome. Awesome. Very good job. Yeah.
Kewaskum gets more amounts of rain per year than West Bend and Slinger.
Okay. And we could even get more specific about it. We could say that Kewaskum gets 2 more centimeters than West Bend. All right. And so on. Okay. So this is an example of a table. All right. Very easy. We make sure that we put all of our information onto the table. Any questions about tables? All right. Moving on. Okay, then what happens is that we get into our line graphs, bar graphs, and circle graphs. But before we can do any of that, we need to understand a definition, all right? Usually when we get into line graphs and bar graphs, we start to see that we have kind of this up and down line and a line that would be cutting through, all right? And we start to refer to things like a vertical axis or a horizontal axis, but we stop calling them horizontal and vertical by the time we get into middle school and high school because of the fact that they're given a more specific name.
What?
Okay? The name of the vertical axis, yep.
Y-axis?
Very good. When you make a capital Y, it comes straight down. And so if you can remember that your Y comes straight down, this is known as the Y-axis. And because the X cuts through, okay, this is going to be the X-axis. Okay, so let's give a definition to each of these. The Y-axis is going to be vertical axis or up and down. And the x-axis is going to be horizontal axis or side to side. Okay?
Just hold on.
Yep. so our y-axis is the vertical one, or going up and down, and the x-axis is the horizontal one, which is going side to side. So from now on, we have to be able to refer to them as y and x-axis. And when you were doing the M&M lab, you had to put some labels on the x-axis and on the y-axis. And now you should know the difference between the two of them. Okay. Any questions on x and y-axis? All right. Then let's start with the simplest of them, which is the bar graph.
Hey, what was that?
Okay, the bar graph is going to compare a set of measurements or the amount of change. Okay, I'll let you get that copy down. But we know that we're going to be looking at a set of measurements and how much change comparing them to each other. Okay, so that's the bar graph. Now, when we draw the bar graph, we know that we have our lines. Remember that this is the y-axis, so we start remembering that. This is the x-axis. Usually, this is going to be the dependent variable, and this is going to be the independent variable. And usually this is going to be numbered 1, 2, 3, 4, 5, etc. And down here you have your independent variables. So with the M&M lab, these were our numbers. Okay, so we had our numbers that were right here. And we had our different colors. So you had like blue, red, brown, yellow, green, orange. And for each color, however many M&Ms you had, you drew a bar graph. Okay, and some of them were taller than others because some of them you had more than others. Okay, and all you do is you make a bar that is going to represent the value of each color. Okay, so we're comparing a set of measurements or amount of change. The change is the different colors, and the amount is going to be the amount that you had in the bag. Okay. Any questions on bar graphs? All right, moving on. The next one is going to be a line graph. Okay, so we will look at a line graph here in a second. Bar graphs and line graphs are very similar to one another. Instead of drawing bars to represent how many M&Ms you had, instead this time what you did is you put a dot to show how many M&Ms you had. Okay, so I'm going to scooch it up a little bit. And this one is going to be called a line graph. And when we are working with a line graph, we are showing changes that occur in variables. So changes that occur in variables. Again, you are going to have your line. This is your y-axis. This is your x-axis. And imagine that we took 5 bags of M&Ms. Okay, and we had our numbers that were over here. and we had our colors that were over here. So let's say we had brown, and let's go blue, and we'll go orange. Let's go yellow. Okay, we'll just do those colors for now. But let's say we took and added up all of the amount that we had in the different bags. Okay, and we added them all up and we counted them and we said, okay, in one of the brown bags we had, on average, we divided it by the total number of bags. Let's say that we had 3 bags per each brown one. And for the blue, there was only 1. And we'll say the orange had a total of 5 averaged. And we'll say that there were 0 yellows. Okay? And so what we could do is we could draw our lines. So we connect the dots. And now we have a line graph showing us each one of the numbers and how many there were to try to find a trend. And we really don't use line graphs for this kind of stuff. We use it for changes that would occur. So a good one to use would have been when we were making our table of cities and amount of rainfall. That would be a good one to plot because we could just look at Kewaskum and we could take each month and plot down the data. But either way, you can look at this and see that the highest point is at 5 for orange, and we could make a statement about your bag of M&Ms. We could say, what, Dakota?
Orange is the greatest out of all the colors.
Okay, out of the 5 bags of M&Ms, on average, the orange had the highest amount in each bag. Very good. Okay, so that is a line graph. Any questions on a line graph? All right, next one and last type of graph that we're going to be working with is going to be called either a circle graph or a pie chart. Okay. And our definition of a circle graph or pie chart is that it is a part of the whole chart or graph. So if you remember earlier, very early in the school year, bless you, we took a look at our breakdown for our class in terms of how the class is made up. We said that if you think of our class as a pizza or a pie or something of that nature that has the circle shape, and we said that our grades are going to total up to a total of 100%. Okay, that's what our class is going to be made up out of in terms of different parts of the class, different sections of the class. And I said to you that half of the class is going to be made up of test grades. Okay, so we said 50% of our class, your grade is going to be made up out of test grades. Okay, so 50%. Half of it. Half of the class is going to be made up out of tests. Yep.
Wouldn't the other half be participation?
Nope. We go through. And by the way, if I was to draw a line that went right across here, splitting these into 2 equal parts, what would each percentage value be?
25,
Zoe?
25.
What would be the amount? If this is 50% right here, and I drew a line that was splitting these 2 equally, how much would this one be valued at?
20.
Okay, think of a dollar bill, because this is a whole.
Think of
Okay?
20.
If I break the dollar bill into 4 equal parts, okay, and I took 2 of the parts, saying 50 cents is over here, how much is left? 50. And if I split that in half, what's half of 50?
25.
Very good. So if I was to split it, but we didn't split it equally because of the fact that we know that our tests are 50%, our quizzes are worth 30%. Okay, so our quiz grades are worth 30% of our overall score, giving us a total of 80%, which leaves 20% still available.
Well,
And we said that 10% is going to be blogger, which we are now at a total of 30 plus 50 plus 10 more is 90, giving us 5% for labs and 5% for assessments, which is homework assignments. Okay? And so 50 and 30 and 10 and 5 and 5 gives me that total of 100%. All right? So I have my total. Now, based on that, we said our definition of a circle graph or pie chart is the part of the whole. So if I asked you, Kiara, what the largest part of the pie is, what would you say? Tests. And it's 50%. So 1/2 of our class, your grade, is made up out of tests. Okay? If I asked you what the least amount of grades being made up, yep.
The least amount of the grades made up would be assessments and labs.
Very good. Okay, and so what we've done is we are able to translate information from a chart. So we're looking at the parts of the whole. All right, the whole is 100%, and we're breaking it down into smaller little chunks. Okay, so we can understand it. All right, almost done. Last note that we need to make sure we are aware of is the idea that scientists are able to share their results or data with people through magazines, internet, newspapers, and another way could be conferences. And I'm sure there are other ways too, but I just wanted to give you a couple ideas. Okay, so what does that part of it mean? That means that once they have results of different studies that they have done, okay, they are able to share out their information not only through graphs but through written work that comes in the form of magazines, internet, newspapers, and conferences. Okay? So let me show you an example, and then I'll bring this back up so you can finish copying. But if I was to go to a website called ScienceDaily.com, you can see that this is an example of where they have health. They have different articles that are written by scientists that deal with all sorts of health, physical and technology articles, environment type articles, science and society and education, and quirky articles. So here's an example of where you can find all kinds of different articles that have been published by scientists. So for example, monstrous ice cloud on Saturn's moon Titan. So you could see that this article is published by NASA, and this is a whole long article that shows information about that sort of thing, and so on. And you could go back and look at all of these things and see that there are data sets that are in some of them, and you could read the articles and such. So that's one source. Another source that we have is I get a magazine every week. It is called Science. Okay, this has a bunch of information in here, and it always has some type of research article that was done, and oftentimes there is a graph, which you can see up here at the top. So you can see that science data is printed in form that way as well. And if we wanted to go one last step further to newspapers, we could go back onto the internet or into the newspaper itself. But if I went to New York Times, you can see that there's a section that's devoted to science and health. And so you could click those and take a look and read about it as well. Okay, so that is the end of the section.